I'm wishing myself luck.
There's also a short delay of roughly 20 seconds or something like that.
Yeah.
So
Can you share me the link on which it would be going live? So I actually
I can share it to you. Yeah. No worries. And I think we're already live. So hi folks, and welcome to this session. Let me just mute this one here. Cool. Right, and welcome to this month's session of the Virtual Kotlin User Group. As always, feel free to subscribe and click the like button somewhere down there. And with me today is Himanshu. Hi, mate. How are you doing?
Hey, I'm good. How are you?
Yeah, not too bad at all. Not too bad at all. I'm so happy to have you on. Thanks for volunteering. Well, ish. I kind of pushed you, so it's fine. And I'm really looking forward to your talk. And yeah, as always, if you have any questions, folks, just put them into the chat, and then I will collect them and will relay them to Himanshu. So with no further ado, it's all your stage.
Today is Himanshu. Okay, I'm so sorry. Yeah, so hi everyone. I'm just here. Like, thank you for having me here. How do I pronounce it? I'm a bit confused. Holger, right? Yeah, perfect. I did it right. Awesome. So hi everyone. Yeah, so this is my technically the first talk I have been doing in a long time. I just hope this looks good. My PPT there. I'm not pretty sure how does it look right now. Just a sec, let me. Yeah. Is it coming full screen somehow? I don't think so.
Well, that's interesting. I haven't seen this. But anyways, if you leave it this way, it might be all right. So you could, if you press F11, I think it is, for full screen, it should put your screen in full screen. All good. Take your time. Here we go. And it's full screen. Perfect.
Awesome. Yeah. So just let me set it up. I'm so sorry. Everything is going haywire right now. So yeah.
Oh, good.
Yeah. So I'm here to actually talk about Kotlin Flow and all things stuff related to it, right? So even before starting something around it, I'll give a very basic introduction about what I have been doing, who am I, and stuff. As like basic, who am I? So I'm a Google developer expert for Android. I am into speaking and blogging a lot of things about it. Recently, it has been I've been able, but let's see, I'm starting again. I like to contribute open source. I have built a couple of libraries, and yeah, as a professional skill, I am working as a senior Android engineer at Roomi. So that's all remote. So yeah, even before pandemic, I was working remote. So now this is going to be a very basic agenda stuff for right now that we have to understand what we are going to understand and see today. So first, we are actually going to see a problem, what problem we were actually facing, right? Then how did Kotlin solve it, and how alongside the flow, when it came alongside Kotlin, it also solved it, right? Then we'll understand how the design architecture of Kotlin Flow is, and we'll touch upon coroutines as well. So we're going to do for both. And as a later aspect, what we are going to do is we are going to see a very couple of real life examples how we are going to migrate from other Rx libraries like RxJava, for example, or any synchronous code to Kotlin Flow. So yeah, as an agenda number one, we had to understand what the problem is, right? Synchronous execution. If somebody doesn't understand in a very basic terms what is a synchronous execution, just think this as of something which executes line by line, right? This has been the paradigm of programming since how long? I don't even remember. Like, let's say that when a line executes at line number one, after that, line number two gets executed. After that, third line gets executed, and so on. So, this basically is an example of synchronous execution, right? So, when we talk about synchronous execution, what exactly happens. So don't expect line number 3 to run even before the line number 1 has run. So that's what synchronous execution is. Like it would start executing line by line. And it can't jump lines like from 1 to 3, or let's say that the first number which executes would be 4, right? So that's how synchronous execution is. Like let's consider this a very basic example. You have username and password, right? We enter both of them. Let's say I enter username as Himanshu Singh, I give my password, and when I press login, we do that execution, right? That's a synchronous execution. Now let's say we have to get the user detail of that specific username Himanshu Singh. So how do I do it? So when I press login button, I do a login, and as a response, I get a user ID, correct? So that user ID, I'll pass it to a new function, or let's say a new API, and I'll get the user detail. So just see the synchronous execution there. First, we passed on the data like email and password or username as password, and then we did login. From the login, we get user ID, and we used that ID to fetch a user detail, correct? So that's how we have done the synchronous execution right here. Now, let's talk in a very basic engineering term. What's the drawback of synchronous execution, correct? When we are developing an Android application, right, you might have heard there's something called main thread, or as we developers actually love to say, we have a UI thread, right? So what's the drawback and why I'm discussing UI thread right now? So when you talk about a synchronous execution, let's say that executing from line 1 to line 2, line 3, line 4, all of that actually executes on the main thread. And when it happens on the main thread, your main thread gets blocked, right? So let's say that if we do some heavy task, this login mechanism is not a heavy task, right? It's just doing like entering two things and getting an ID and fetching a user detail. Let's say we actually get a list of users by some synchronous execution technique. Let's say that in place of user ID, we pass, let's say, the region ID, let's say London, and we want to get all the users from London. We can have a paginated list, right? But it would have a list of items, and it would have a plethora of items, so much that it might actually block your main thread or the UI thread, right? So that's a drawback that we might mistakenly or we might knowingly do any type of execution which actually would turn out to do a lot of work on the main thread, which might block your main thread, right? And in Android, everything works on the main thread, right? If your UI gets blocked, your app is frozen, right? So that's the drawback of synchronous execution. Now, this is where asynchronous world came into the picture, async and stuff, right? Now this is where things get interesting, definitely. So we have a couple of options for asynchronous programming coming ahead. So one is threads, our favorite anytime, right? We have threads inbuilt for Java mechanism. Then RxJava, and I'm pretty sure like major of the big apps already have RxJava if they have not started porting towards coroutines, but almost all apps which were production ready had RxJava installed. Now this is my favorite one, like not just me, but every Android dev's favorite. We had asynchronous tasks, and I'm just kidding right now, but everyone used to love async tasks, right? Unless it was deprecated and we started running around for solutions. What should we do? And now, at last, we have something called Kotlin Coroutines. Now, this is the hottest topic right now for me, if I would have to say, in the Android ecosystem, that everybody is like, we'll do coroutines, we'll build this, we'll build that, right? So this is one of the best aspects of it. Now, apart from all the four options we saw, this is what we are going to discuss, right? Like this is what I'm being asked to deliver a talk on, Kotlin coroutines and flow. So we'll start with coroutines first, right? So let's understand first what's coroutines, Kotlin coroutines. Like it's just another mechanism of asynchronous world where you can help to run something asynchronously. So if you see that if you have two different tasks, it might run on two different threads, and it would not block something on your main thread, right? So Kotlin Coroutines is all about that, right? How is it better? This is a question, like I would say $1 million question that everybody asks, that we already had RxJava 2, we are coming up with RX3. How is it better, right? So now let's take this example itself, login example, right? Now you know what the process is. You have the username and password, and then you get the user ID, correct? Using that user ID, you get fetch user detail. So now you'll see we have two functions here. First function we have is do login, which takes username and password. And then we have another function, let's say fetch user detail, which takes a user ID. This is pretty similar how we write a function in normal Kotlin, right? But if you see, we have two things specifically added in front of a function. We have a specific keyword called suspend, right? So when we make a function suspend in Kotlin coroutines, it basically means it would be not running on the main thread, and we need to specify where do we need to run it, right? So suspend is added in Kotlin coroutines to make a function suspended, right? And now let's see how we can call it. It's pretty similar how we were actually calling in the synchronous execution, where we were calling the function do login. We were returning a user ID out of it, and we were passing that user ID in the fetch user detail function, right? So basically, if you consider the do login function as step 1, then fetch user detail is step 2, correct? So inside that launch, you are actually calling do login and then fetch user detail. So it might look like to you as it's a synchronous execution, but it's technically not, right? Because it's not running on the main thread. Now it would be running on a worker thread inside a scope, right? So what's the magic inside that? If you remember 2 slides back, we actually added a suspend keyword to both of these functions. The first function was do login. The second function was fetch user detail, right? So if you need to call a suspend function, it can be only called either something like a scope, which can be a lifecycle scope, a coroutine scope, a view model scope, anything. Here, so as a generic name, I gave it as scope.launch, or it can be called from inside another suspend function. So this fetch user detail can be actually called from do a login function, because it's a suspended function as well, right? So now let's understand when we talk about the scope thing, right? As I mentioned, there are a couple of scopes: coroutine scope, there is a global scope, there's a view model scope, there's a lifecycle scope. It's basically a container which scopes a coroutine, basically the suspend functions. So it's basically a collection where it will run. So let's say it's basically like a CPU which will run that execution which is mentioned there, right? So we had two different functions, do login and fetch user detail. So that's a scope. But that's $1 million question. How is that not running on the main thread, right? How does that magic occurs in Kotlin coroutines that gets executed not on the main thread or the UI thread? That's the biggest question, right? So basically, we are suspended, or as I would say, you are suspended. So now if you can relate it, it's just a UI mechanism or the fancy way to say it, but is that the suspend keyword which we were using initially in front of the function, which is making it very unique to change, or how it helps us to run not on the main thread, right? So this was the thing which we were doing, right? Inside a launch function, we were calling do login. We were getting a user ID, and that user ID we were passing in fetch user detail, right? Inside that whole launch thing, right? In the scope. So in this function, when we did this login, right, it didn't run on the main thread. It was running inside the container scope, which we specified, right? So what does this suspend function actually do for us? If you notice it very clearly, isn't it all the functions we declare in Kotlin is pretty same how we do it, right? I'm not sure. Maybe if somebody can tell me if there's another way to declare a function, there might be, but this is a very generic way, right? In Java and Kotlin, how we declare a function. So if I consider do login as a function, it's a function where we have a username, we have a password, correct? And inside that function, there might be something happening. And let's say an API call via a use case or a repository, which returns a user ID. That's roughly it, right? But that's a normal function how it looks like. But now this is where things get interesting. Now when you decompile this suspend function do login, so if I say you have to decompile this do login suspend function, you would see a new parameter, not just to username and password, but now you will see username, password, and continuation. So this a continuation is basically like an interface or a callback which gets added because we have added the suspend keyword to a function, right? So now let's understand this. When you are breaking things down, correct? Like let's say decompiling it. Now this function do login would have a username, a password, and then a continuation parameter as well. Now it looks like the generic or the normal functions of Java or Kotlin, right? So what exactly is this continuation? Let's check that out first. So continuation is basically like an interface which has two different stuff, a Kotlin coroutine context and a resume with. Now, coroutine context is the context in which the coroutine has to run. Basically, the scope has to run, which we are using, scope.launch. And resume with actually passes on the results. Now, going ahead, this resume or the continuation actually has two extension functions as well. There is a resume and there's a resume with exception. So let's talk about resume first. So let's say when we were executing the whole flow, right? Let's say when we did a do login and we got a successful user ID, we'll use this continuation dot resume and we'll pass the data here, right? And let's say by any chance some error pops up, maybe on the exception thread, like network exception or any exception or error comes up, we'll use that to pass it using resume with exception, right? So this is where we are going to throw the result. So now we have continuation and we have two different extension functions for it. One is resume, which passes on the result if it's a success, and there's a resume with exception if it passes on, if there's an error or an exception throwing up, right? Now, this was how internally coroutines works. So if I go back a couple of slides, now do login with username and password parameter are a function which is a suspend function. When we decompile it, we see it like this: function do login. It has a username, it has a password, and it has a continuation callback, right? That callback now looks like this. I'm just summarizing everything. It looks like this, which has a coroutine context, and it has a resume with function as well. So this is a context where the coroutine would run, and resume with actually returns out a result. Now this continuation itself has an extension function. One is for a success callback, another is for a failure callback, like how we do it for retrofit, right? Now, let's discuss what is actual benefit of a coroutine. Like we talked about anything and everything, right? How it is being made, what's continuation are and stuff, how we decompile it. But let's understand the coroutine benefits first, right? So when I say this benefit, it means that it's so lightweighted that I can say you cannot run 1,000 threads at one instance, but you can run 1,000 coroutine scopes at one point. So internally, coroutines actually uses the thread pools to run efficiently on the Android end, and it's so lightweighted that it would not increase your app size, right? So that's one of the best parts. Now, going ahead, everybody's actually planning to port your app to Kotlin. And when you're building with Kotlin, you just need to add a more dependency, and you get coroutines out of the box for Kotlin. So it's the best part of using it. It's lightweighted, it's fast, and it uses thread internally to manage everything stuff, right? It's basically like a state machine which changes on which thread it has to come. So if you remember, right, this resume in the do login function, when we return a user ID, it uses this resume. It takes the user ID here and returns on the resume. When the function gets the user ID, then the fetch user detail gets executed, right? This is how it is done. So it's basically like switching the threads in what it has to do. That's one of the best things. Consider if coroutines, right? It's a statement which you can actually relate to. With coroutines, it's more like a one-shot thing. Like you do it and you forgot. Like it's an API call per se, if I have to give it that way. That in API call, you do an API call, you get that data, and that's it. You do whatever you want to data. You don't want the flowing of data, right? But what if you want to do it? If you want to flow it, invokes the Kotlin flow. So I think the name itself exposes it, right? So when actually coroutines came into the picture, everybody was like, coroutines is an actual replacement for what do you say, RxJava and stuff, right? But I actually feel coroutines is not the replacement of Java, RxJava. Coroutines with Kotlin flow, the collection of these two is an actual replacement mapper of Rx, right? Kotlin gives you the threading mechanism, the threading model of RxJava. Kotlin Flow actually gives you all the relevant operators and the easiest way out if you want to do it. And then it's an actual replacement of Rx, right? So let's get a basic idea about Kotlin Flow first. Kotlin Flow is null safe, like how Kotlins are actually, right? Null safety is there. Kotlin can be used with other reactive streams. Third thing, which I mentioned, it has amazing operator support, right? How RxJava had what it was the prime thing of Rx, and it had a lot of operator support. Now it handles back pressure directly, so you don't have to write an explicit set of code with Kotlin Flow to handle the back pressure strategy for the flowing of data, right? And this comes the best part. Now everybody has explored Flutter, React Native, but a lot of new developers have started porting their code or maybe starting this Kotlin multi-platform thing, right? And Kotlin multi-platform is just have the logic, the business logic as a shared code, develop your own UI and expose the data set from here, right? So Kotlin Flow actually supports Kotlin multi-platform out of the box, right? Now, let's understand the basics of it first. It's a very basic thing how we need to understand the Kotlin flow. And this is how we are going to plan it out, right? Even before understanding the logical things, let's go to starting part. So if you see, we have a function of numbers. We used flow of, right? And then we have emit 1, 2, 3. In flow, emit basically means it throws off the value, right? So here we are throwing off 1, 2, and 3. And this number is actually of type flow of integer. So function number, it has a return type of flow of integer. Here I have created it as an expression function, but if you want, you can have function number, a return type of flow of integer, and the builder which we have used, flow of. So basically flow of is a builder to build a flow, right? There are a lot of different ways to do it, but this is also a way of building a flow. So flow of, and it emits 1, 2, 3. So you can return this and it would be start emitting value or throw the value. And now if we want to collect it, we'll do it like this. We'll call the number function and we'll just add this collect operator there. Inside this collect, there would be all the values being emitted, which are actually 1, 2, and 3, right? So numbers.collect and it's started emitting here, right? So let's say one of the things which I have to actually mention, right? That flow would not start emitting value at the instance, right? It would start emitting the values only and only if this collect operator is being attached to this flow, right? So when you attach this collect, then only it will start emitting the value, and it will start receiving the value from the first instance, and it would not start receiving from middle, because the collect operator is used to get the values from the flow, right? Now, an interesting topic here, like a lot of people want to actually export your RxJava code, or let's say migrate from Kotlin Rx to Kotlin Flow, right? I have a couple of snippets here where you can map it out, how it looks like, right? So it's an observable of three numbers, 1, 2, 3, and you just subscribe to it and just listen to 1, 2, 3, right? How you get it. This is the same way how you can use and flow of 1, 2, 3, and you can collect. So if you map it out here, it's still the same observable, just 1, 2, 3. It creates an observable of three numbers, and this creates a flow of 1, 2, 3 as a number, and you can collect the values here, 1, 2, and 3, right? So this is how you can emit a value. Like if you see here, we first emitted a value 1, 2, 3 specifically, and we used using flow of emit, right? Here you can use flow of, and you can just pass on the numbers here, and you can collect it out. So that's another way how you want to do it, right? Now we got the basics right here. How we can export something, numbers. You can pass on the string as well. You can pass anything. This was just a basic example to make you understand how things actually work, right? Now, this part, we first understood how Kotlin coroutines worked. Now let's understand its counterpart, not counterpart, just a part which helps it to run flow, how Kotlin flow internal works. So we have a flow, right? As I said, this function would return a flow of integer. So we have a flow, right? So that flow is basically an interface. This is how it looks like, flow, and it has a function collect, right? Suspend function. So if you see this collect, which we are talking about, it's an interface. So on flow, there's an interface called collect, which takes collector of flow collector, right? Now let's see this flow collector. Flow collector is basically a suspend function which emits a value. So in hindsight, if you see, the Kotlin flow internals has two interfaces. The first interface is actually flow, which has a suspend function collect, right? It's a generic, right? Like you have the T and all. That's a basic stuff. But on a bigger level, it's an interface which has a collect function, and that collect function has a collector of flow collector type, correct? Now that specific flow collector is also an interface in flow, right? And that has an emit value. So we can emit a value from this point, this interface itself, and this flow interface would start collecting the values. So basically, these two interfaces, emission and collection, that's it. Like how you saw for suspend functions, if I have to build up that way, right? In suspend function, if you broke it down, like you first had to break it down, you get the parameters of the function, and apart from that, you get the continuation callback coming up there, right? Now that continuation callback again had a coroutine context and a resume function. Now the continuation itself had two extension functions related to it, resume with and resume with exception, correct? One was for a success callback and another was for an error callback, if I'm not wrong, right? That's how the internal buildup was, and that's how internally it was to switch. But when you talk about Kotlin Flow is actually built up of these interfaces. The first interface has a suspend function of collect. The another interface has a suspend function of emit. So basically, this emit and collect, this is the mechanism. I emit something, you collect something. It's basically like I'm delivering a speech or a session right now. you are viewing it. So it's an emission and collection. That's it. That's Kotlin Flow for you. Now, if you noticed it very closely, both of these functions, like the collect and the emit, are suspend functions, right? So when you see this suspend function coming up, you go back to the Kotlin coroutine thing, right? That you have a suspend function, and to run this function, you have to use the scoping mechanisms, right? It can be a coroutine scope, it can be a view model scope, it can be a lifecycle scope, but to run this flow, you can't run it directly. Either you need a scope to run this suspend functions, or you can call it from another suspend function, right? So that's how flow actually works internally. Now, this is a topic, one of the topics, interesting topics, how we can migrate from Rx to flow, right? Now, consider this. I'll be talking about like a retrofit or an API example if in that case. So we have a fetch people function where we have a query of page size, and queue as a query string which we can pass. Now, if you see, it's a get call. I have passed on all the details there. But on the return side, if you see, we have observable, right? It's the Rx observable, which returns the response of list of users, correct? Now, if you have to change it in Kotlin core routines, right? And if you have to migrate it, let's say in that way, you can first add a suspend keyword in that place, right? And you have to remove that observable from this response string, from this one. So now that's how you can migrate in the interface of the repository, of the interface, sorry. Now, in the repository, what you can do is you have to create a function fetch people. So you can see page size, I have given a default value of 20 here, right? So in the repository, what I'll do is I create a function fetch people where I'll pass page, like on what page number the data I want to be, and the query string which I want to pass. Now, if you see the return value here, the return value is flow, and we have again the response of list of users, right? Now we have the same thing if we have for repository implementation. You can see if it returns observable, right? You will just return user API.fetch people and stuff going around. But if we have for flow, the function which we created, func fetch people with page and a query string, and if we have a return type of flow, right, a response list of users, what we'll do is we'll return a flow which emits a value user API.fetch people. In place of page, I'll pass the page which we have in the parameter and the query here. Now, this specific return thing will return a flow and it will emit a value of user API, right? This is, I'm explaining you in a very layman term, but in a generic production code, you don't do it like this, flow of emit something. You have a basic, let's say, a wrapper around this, let's say a perform network call as a wrapper. And inside that, you'll just pass user API.fetch people. And internally, we would write that wrapper which returns a flow and emits something, right? But here, for a very basic example and an understanding, I'm giving you a layman explanation that will return a flow. So if you remember, we had a flow of as a flow builder. We also can use flow, and inside that we are emitting this value. Now you can see this returns the flow. This will return that specific fetch people in the emit, and last, this is a flow on. Where do I need to return or run this thread, right? Run this execution. So this is where flow on comes up into the picture. We have dispatcher.io. That basically means I'm running it on the IO thread. There's a main thread, there's a default thread, but here I have passed on the IO. So I'm just running it on the IO thread. And this is how you can have the repository implementation of that repository. Now, technically we would have a use case layer as well coming up, but now I'm just skipping it out. I'm just doing view model scope and I'm launching it out, right? So this view model scope is the scope in which this suspend function or this flow is going to run, right? So when this flow is going to execute, it would be scoped inside that specific view model. Let's say that if this is being scoped in a main view model, then this fetch people function is actually going to run inside that main view model scope, right? Now you can see a catch block and you can see a collect block, right? So inside this catch block, let's say any exception occurs, like an on failure state comes up, this catch block is actually used to catch all of that. Let's say that there's an exception that the input parameters are wrong, something doesn't match out, it would be there. And inside this collect at the last, we'll start seeing all the data coming up. It's a success one, right? That's how you can use this repository implementation function in the view model, where you first launch it in a scope, then if any exception or anything comes up, you do it in the catch block. Let's say that if a network exception, you might have to throw an error saying that no internet connection, that would come up here. And in collect, you will start receiving the list of users for that specific parameter. So that's how you can use Flow with with the API calls. And this is the same way how you can relate with RxJava with Kotlin Flow, right? So that's one of it. Now, there's another section to it where you might have seen there are a lot of different uh, apps which use Rx bindings, right? You can also actually have a flow binding. You can create your own. So either you can actually use a library, there's a library of flow bindings, or you can have it one. So basically the agenda to make you understand what flow bindings are, right? You have to convert a callback. Let's say a set on click listener, for example, per se, right? You want to return it as a flow. That's the use case of this topic, like the agenda of this topic, what we want to do. So flow bindings are basically going to be that part where we are going to convert any bindings to flow, make that the subtitle shows, right? Make type things to return flow. So let's say we have this, right? Add text change listener, which has a text watcher, and it implements couple of functions of it, right? After text change, before text change, on text change. So till now, what we are doing is we have been doing is as we actually do edit text dot, and then we call this add text change listener, and we implement all of these, right? Correct. So inside this on text change, we have been doing all our checks, and let's say that what have we entered or something like that, correct? If I'm not wrong. Now, the agenda for this slide was actually to convert that specific thing into a flow. So what I actually did, I first created an extension function of add text change, right? And now it is returning a flow of string. So why I'm saying a flow of string is the reason because I want to return it as a flow, right? And I just don't want to pass it via lambda or something. So I created an extension function which returns a string of flow. Now, this has a callback, right? Like it has an add text listener, add text change listener, it has a text watcher, and all of its function, right? So we have to convert that callback. So for that, if you want to convert a callback to a flow, you have a way or a pattern which known as callback flow. So inside that callback flow, you'll pass the callbacks of that specific thing you want to convert. So I wanted to convert add text change listener. So I'll pass this, the edit text reference. I'll add that add text change listener to it. And if you can see in the on text changed, where we actually used to do a lot of things previously, now here I'm not going to actually do anything here. What only thing I'm going to do is now I'm getting the reference of the callback flow, this flow, right? And I'm going to offer the things which I want to return. So consider this line, this specific line, as a return p of 0 to string. So basically I'm returning that string here, but I'm just not returning a CRUD string, I'm returning it as a flow. So if you want to return a string or any value per se in a flow, in a callback flow, you have to offer it out. So this is how you offer it. And when you are done emitting that value or offering that value, you also need to close that, right? So for that, we have this await close, and we again get the reference of edit text, and we pass null as the listener. So you see what actually happened here, right? First, we had this edit text extension function where we added add text change as the name of that extension function, which returns a flow of string. Then we used the callback flow here, and we used the reference of edit text using this at the rate add text change, right? Then we added the listener to it, the add text change listener. We passed the text watcher. Then inside that callback flow block, we offered that string p of 0 dot toString, right? That's the basic way how I returned it. And when I was done offering or emitting that value as a flow, I closed that listener. I nullified it basically. So that's how you can convert a callback into a flow. So that's how a flow binding works. Now consider the same example as for let's say a set on click listener, right? I'll use func view dot set on click listener, and that would also return let's say a callback flow. Inside that we'll use again an offer, and I will open a block up there, right? We'll do something like that, and that's await. So basically we can convert a flow of string, or let's say a set on click listener as a flow, right? So that's how you can convert a callback flow. Now the next aspect is flow as a data holder, right? Till now we saw flow as a mechanism to map out your data from coroutines, use certain set of operators, we can catch the exceptions, we can collect the values. We have a lot of different problems, operators there. Now the next topic we are going to discuss is flow as data holders. So for us, data holders has been actually something like live data, right? But in flow, we have something called mute state flow, right? So this is what we mean as flow as data holders. So we are going to state our data here, right? So now see this in state flow. We created first a mutable state flow with an empty string, right? And we have assigned a value of username. If you remember, this seems pretty similar how we use it for val username is equal to mutable live data of string. But here, and the only difference in both of them is definitely of the spelling, yes. But here you can see we are passing a default value, a string here, right? But in live data, we never used to pass a string here. And now we return a immutable state flow of string of name, right? That username is basically editable where you will set the data, but when we have to, like, let's say observe it in the live data terms, we are going to observe this name variable. And this would generally be as a private variable in your view model. Now, let's say that when we set a value, right, very used to do in live data was username.post value, and we used to pass a data. So here I'm passing Android worldwide as username.value is equals to this. So this is how I'm setting the data. So let's say that I have an edit text which I'm setting my data. I'll set my data as username.value and Android worldwide, right? Now, the next step would be how I observe this username, or basically not username, but this name specifically. So this is a flow. So in any case, you need to catch or collect it, right? So if you remember how we collected a flow, so name dot collect, and here I'll get this specific value, whatever I set. Now let's say if you want to do some filter stuff, or let's say some other thing, you can add a lot of different operators here, name dot, let's say map it out, or let's say switch map, anything you want as an operator, and you can collect it here. In this collection, you would see this Android worldwide being coming up, and you can do whatever you want to. Let's say you want to set it to a text view, or let's say you want to do an API call using that, anything you want. That's how you can collect it. So, okay, we are almost at the end. So I'm just going to summarize the things that we had a discussion on first. We first understood Kotlin coroutines on the very basic ground level, how coroutines works, how coroutine internals are built up, what continuations are, how do we run a scope into it. Then we saw how flow works, how we can use flow, and how Kotlin flow and Kotlin coroutines love each other, right? They work in a conjuncture of each other. Like flow would not run without coroutines. So that's a mandate step. They both basically love each other. Both of them, if let's say that if flow supports Kotlin multi-platform out of the box, that means coroutines also support them out of the box. When you use a flow or coroutines per se, you don't impact the size of the app that much. Like it's a very lightweighted library, I would say, that would not impact your size. And at last, we actually went with the whole flow, right? That's what's the whole execution theory, what we did. So we understood all the different aspects, how you use coroutines, how you have a flow thing, and how you can use flow. We learned flow as a flow binding thing, how we converted a callback, right, at text change listener into a flow. We saw how we can use flow as a data holder, and a lot of different aspects going around there, right? So this was the whole summarization of the thing. Thank you so much. It has been a long session, so sorry. I might have bored you out, a lot of people, but thank you so much for listening. Thank you.
Well, that was a well-flowing presentation, I would say. Sorry, couldn't resist. Well done, thank you. So let's see, let's give our guests a couple of seconds or minutes, well, seconds, to put in some questions, because so far it looks like you described it so well that there are no questions.
I tried my level best to be in a very basic level terms.
Perfect. Okay, so it looks like we don't have any questions, which is absolutely fine. You just gave us your Twitter handle, so I think if anyone has a specific question for you, they can contact you on Twitter or, as always, on Kotlin Lang Slack.
Yeah, definitely, I'm there.
Perfect. So then thank you so much for your time. And to all our viewers, thanks for joining. And yeah, join us on Kotlin Slack and join us especially next week, next month again, not next week, next month. And
I have a couple of things to say before we go.
Oh yeah, no, I'm so sorry. Go for it.
No, that's really fine. I just want to say that you should definitely reach out to Holger for if you want to actually come up here. This is an actual good experience if you want to share something of your learnings, maybe around Jetpack, Compose, anything. I would definitely recommend you guys to come up on board and speak out. And maybe I'm definitely saying this. Reach out to him on Slack, Kotlin Slack channel. He's very active there, and just bug him out till he gives you a slot. That's it.
Okay, you actually made me blush. So thank you so much for your kind words. And yes, we are always looking for great speakers like you, Himanshu. So thank you so much. And yeah, enjoy your evening. Cheers.
Thank you.